a pleasure to be with you today at the Media and Learning Conference in the beautiful city of Leuven. Um, as you said, my research involves applying the science of learning to education. My colleagues and I have been conducting over 200 experiments aimed at developing evidence-based principles for the design of multimedia instruction. And today I want to share some of the fruits of that work with you. So, greetings from Santa Barbara. This is where I hang out. The psychology building is kind of in the right there, about a block from the beach. Um, just by way of introduction, I want to point out again that what I'm trying to do is see if we can take what we know about the science of learning and apply it to education. And that really involves three related topics. First, the science of learning, which is the study of how people learn, the science of instruction, which is the study of how to help people learn, and the science of assessment, which is how to determine what people have learned. So that has kind of occupied my mind for the last several decades. Um, Let me just very briefly try to explain how I'm looking at how meaningful learning works. Some of you might be familiar with this flow chart of ours. The idea is that if a student is presented with a multimedia presentation consisting of words and pictures, um, that information enters through their sensory memory, where it's held very briefly, either through their ears or through their eyes. Um, then some of that verbal information is selected for processing and working memory. Some of the visual information is selected for processing and working memory. Working memory is very limited in capacity. In working memory, we build a verbal model with the words and a pictorial model from the images, and then we work on connecting the corresponding verbal and pictorial material, integrating them with each other and with relevant prior knowledge activated from long-term memory. So that's the arrows are really the active processes in meaningful learning: selecting, organizing, and integrating. When it comes to instruction, given that working memory capacity is limited, um, our architecture is such that when the information comes in, we don't have a lot of capacity to process it. So there are three basic categories of processing during learning: extraneous processing, which is just wasted processing that doesn't support the objective. That can be caused by poor instructional design that we're all familiar with. Um, Essential processing, this is cognitive processing aimed at mentally representing the material. And this depends on the complexity of the material. And lastly, generative processing. This is our attempt to make sense of the material, and it's really caused by the learner's motivation to exert effort. So this means in terms of instructional goals, we want to reduce extraneous processing so that we have more capacity for the good kinds of processing. We want to manage our essential processing, so if we have complex material, we can handle all that. And we want to foster generative processing to help learners become more engaged and active in the learning process. I hope that all makes sense. In terms of our research studies, in a typical study, we compare learning from a base version of a lesson and an enhanced version. In the enhanced version, it's the same as the base version, but it just has one additional feature added to it, like maybe the instructor is smiling rather than not. Then we look at performance on a transfer test, look at the means and standard deviations, and compute effect size. We're looking for effect sizes that are 0.4 or greater because those are the ones that have the most educational impact. So those are the ones I'm really interested in when we can find something like that. So now that we've kind of had that brief introduction, let me look at some of the evidence-based principles. Um, as I said, we've been conducting hundreds of experiments where we compare the learning outcomes and processes of students who receive a base version of a lesson versus the same lesson with one feature added. And this has yielded a number of evidence-based principles that I want to just very briefly share with you today. So I'll start with my favorite ones, the ones that foster generative processing. So this is an attempt to try and get people, learners more involved, more active, more engaged with the material. Um, so the first one I want to look at is personalization. So let me give you an example. On the left, we have part of a lesson on the human respiratory system that uses, so there's a narrator who is saying during inhaling, the diaphragm moves down, and then there's this animation, which you can see we're not great artists, but anyway, that's a screenshot of one of our animation. On the right, all we've done is take the and replace it with your. So instead of saying during inhaling, the diaphragm moves down, we say your diaphragm moves down, creating more space for your lungs. We didn't put this in red ink. I'm just doing this for you. What we find is people learn better with the version on the right. What's a little bit maybe more self-reference, that's engaging them a little bit more. So, in summary, the personalization principle is that people learn more deeply when words are in conversational style rather than formal style. In 13 out of 15 experimental tests, we're getting a median effect size of 1, which is obviously a large effect. And in all our studies, there's always boundary conditions. I might not have time to touch on all of them, but this one applies probably um, more for beginners or lower achieving learners. The next way to try to foster generative processing is the embodiment principle, which is really a collection of ideas that is kind of emerging. So let me give you an example. On the left, we have a screenshot from a video that's showing you how to build an electric circuit on a circuit board. This is filmed from a third-person perspective with the camera facing the instructor. On the right, we have the exact same lesson with the same voiceover, same video, except from a first-person perspective. And the idea is the version on the right is more effective because, again, maybe there's more self-reference. Maybe it feels like your hands are actually doing it because of the first-person perspective here. Um, Let me give you another version of embodiment. On the left, we have Celeste giving a lecture on the Doppler effect. Um, she's kind of just referring to already drawn graphics. On the right, she's drawing the graphics as she lectures. She's saying exactly the same thing in both videos and has exactly the same illustrations. But the version on the right results in better learning. Again, maybe because of some self-reference. You maybe feel like your hand is there helping her make those drawings. And one last version of embodiment. Um, Here we have a lesson on the human kidneys. Um, on the left, the instructor is not maintaining eye contact. She's either looking at the board or looking off to the side. On the right, in this video, we're using a technology called transparent whiteboard, um, where she can maintain eye contact as she draws. People learn better with the version on the right. So the embodiment principle is kind of an emerging idea, kind of collection of ideas that people learn better when an on-screen instructor is filmed from a first-person perspective, draws while explaining, maintains eye contact while lecturing and gestures. In 16 out of 17 experiments, we get a median effect size of 0.58, which is in the medium to large range. Next, let me look at the voice principle. Um, so these are shots from a lesson on the a lesson on how lightning storms develop. On the left, so this is kind of a narrated animation. On the left, we have an unappealing voice saying cool, moist air moves over a warmer surface and becomes heated. Either a machine voice or a voice that seems very uninterested. Um, on the right, we have an appealing voice, positive human voice that conveys positive emotion. People learn better with the appealing voice. Um, in 5 out of 6 experiments, people learn better when we have a pleasant human voice rather than a machine voice or um, a less pleasant voice with a median effect size of 0.74. So these are all ways of trying to engage learners more. Let me look at another one called the positivity principle. Here on the left, we have a screenshot from a lesson. This is on binomial probability, a video lecture. On the left, the instructor is displaying negative emotion. She has her hands crossed against her body. She has kind of negative facial expression. You can't hear her voice, but her voice also is it conveys negative emotion. On the right, she's trying to convey positive emotion. She's smiling. She's leaning forward. She has a positive voice. But her lecture slides and the content of her lecture are identical. People learn better from the positive instructor than from the negative instructor. Um, in 3 out of 4 experiments, this is kind of an emerging idea of ours. We're starting out here with a median effect size of 0.34, so it's not quite as large as we would like, but um, we have more recent studies where we're getting better effects than that. And the idea is that people learn better when the instructor displays positive emotional tone through gesture, facial expression, body stance, and voice. So I'm trying to smile and have a happy voice. Emotional design principle. Um, this is similar in some ways. We were trying to create positive emotional affect in the learner. In the left, we have slides from a lesson on how a virus causes a cold. This kind of got a little stretched out. Um, in the original version, it's just a black and white line drawing. Um, you can see I'm not a great artist, but it does convey the information. On the right, we have used appealing colors, rounded shapes, and we have included facial expressions for the virus, which looks fierce, and the host cell, which looks surprised. People learn better with the version on the right, the more emotionally designed version that has appealing color and facial expression. This is kind of another version of it where we're using um, characters from the Disney movie Frozen. In 4 out of 4 tests with a median effect size of 0.57, people learn more deeply when the key elements in the graphic are rendered with facial expression and warm colors. So we're trying to really create a positive emotional response in the learner, which motivates them to want to learn, exert more effort to learn. And lastly, in terms of generative processing, we have the generative activity principle. Let me give you an example here. On the left, we have kind of just slides from a lesson on how greenhouse gases affect our environment. There are 4 little videos. Um, on the version on the left, the learner just goes through each one of them and learns about it. On the right, we pause after each video and we ask the learner to please explain what you learned in the last clip. They have to type that in. So that's asking them to engage in a generative learning activity. What we find in 37 out of 44 experiments with a median effect size of 0.71 is that people learn more deeply when they're asked to carry out generative learning activities during pauses in a lesson, such as writing an explanation. Um, so those were all principles for helping people become more engaged. Let me kind of pick up the pace here and look at ways to reduce extraneous processing. Um, so here the idea is extraneous processing is wasted processing. We want to get rid of that so that people have more capacity to engage in the good kinds of processing that I've been talking about. So first, the coherence principle. The version on the left comes from, again, a lesson on how a virus causes a cold. We've added an interesting but irrelevant fact, which can be called a seductive detail. that students at my university found to be the most interesting fact about viruses, which is that in a study in Pennsylvania, found that people who make love once or twice a week are more immune to colds than folks who abstain from sex. So you might think adding that makes it more interesting. The version on the right does not have those seductive details, but people learn better from the version on the right. So this is a case where less is more. In 18 out of 19 studies, people learn more deeply when extraneous material is excluded rather than included, with a very large effect size of 0.86. If we can't eliminate the extraneous material, at least we can highlight the important material. That's what we do with signaling. So this comes from a study with colleagues in China. Um, on the left, um, we have a narrated animation explaining uh, the process of neural transmission, but our on-screen agent is static. She doesn't move. She's not pointing to anything. On the version on the right, she's pointing to the elements that she's talking about. And also that, you can't see this, but it turns red. So this kind of directs your attention to what you should be looking at in the animation as she's talking about it. In 26 out of 28 experimental tests with a median effect size of zero point 0.7, people learn better when we add cues that highlight the main ideas. Redundancy, this is simply saying that people learn better. So this is from the lightning lesson. On the left, we just have animation and narration. On the right, we have added on-screen text at the bottom of the screen. People learn people learn better without that on-screen text. In 8 out of 12 experiments, we're getting like a median effect size of 0.1. So essentially, it doesn't pay to add that on-screen text, is what we're saying with the redundancy principle. That causes a kind of split attention so that if you're reading the text, you can't be looking at the animation. Spatial contiguity. Here we have a lesson on breaks, how braking system works. Typically, the caption is at the bottom. On the right, we've integrated the caption into the illustration and have little pointers to what you should be looking at, like a piston moves forward inside the master cylinder. It points to that piston. People do better with the spatial contiguity, where the words are close to the part of the graphic they're talking about. In 9 out of 9 experiments with a large effect size, people learn better when corresponding words and graphics are placed near each other on the screen. Temporal contiguity, this is kind of saying the same thing for sequencing in time. On the left, we can have the slides first, and then the narration, or the narration first, and then the slides. Those each take 2.5 minutes. So you might think that's better because you're getting 2 exposures, twice as much time. On the version on the right, you're hearing the narration at the same time the animation is showing what you're talking about. People do much better with simultaneous presentation. In 8 out of 8 tests with a very large effect size, it's better to have the spoken words and the graphics presented simultaneously. Lastly, in the few minutes I have left here, let me look at how we manage essential processing. So this is where we have a very complicated material. We can't delete part of it because it's all part of the lesson. So one thing we can do is break it down into smaller parts. On the left, we have a version of the lightning lesson that runs continuously for 2.5 minutes. On the right, it stops after each little segment of about 10 seconds, and you press the continue button to go on. Just allowing people to control the pace of the presentation improves learning. Another way of doing this is when we have PowerPoint slides, instead of presenting them all at once, to present them part by part, progressively. In 7 out of 7 tests with a median effect size of 0.67, people learn better when we have learner-paced segments. Pre-training, which was alluded to in the introduction, here we have a lesson on a car's braking system on the left, on the right. We give people pre-training in each part so they get to see where's the piston in the master cylinder, where's the brake fluid. Um, in the tube and so on. They can click on those and see them, and then they get the narrated animation. People do better if they get the pre-training. In 10 out of 10 tests with a median effect size of 7, 8, people learn more deeply when they have had training in the names and characteristics of the main concepts they're about to learn in the lesson. And lastly, the modality principle, the most studied and somewhat most controversial. Um, People learn better when the words are spoken on, such as on the left, rather than when they are printed on the screen, such as on the right. That's because when the words are on the screen, that creates split attention. Our eyes can not be looking at the animation if they're reading the caption. They can't be reading the caption if they're looking at the animation. So in 18 out of 19 tests that we conducted, we get a median effect size of 1, where people learn better from graphics and narration than graphics and on-screen text. Although on-screen text is better when we have unfamiliar words, when the lesson's in your second language, or when the lesson is slow-paced. So this is part of the team that helped produce these findings, and I'm ready to answer any of your questions.
Thanks, Lucy. Richard, I'm a huge fan, so this is very exciting. Uh, the question I have is super practical, and it kind of is a continuation of the last thing you said. We just have a very practical question. We make MOOCs, and our platform requires us to provide transcripts. So the question is, what is your advice? Do we use the transcripts that are like literal verbatim what the speaker is saying because they contribute to cognitive load, right? You have your modality principle being violated, you got the redundancy principle, but we do have adherence to the voice principle, right? This is with regards to translation. The other way to do it, if we need translation, is to use AI-generated voice dubbing, right? Then you in some instances would not need the subtitles. In theory, your cognitive load would be lower, but it wouldn't be the real voice. So this is kind of something we struggle with. Do you have any advice? Also, what I'm wondering about, kind of connected, if we are free to choose transcripts or subtitles, and by transcripts I mean verbatim word for word, subtitles are condensed, what would be your preference?
Okay. I think you exceeded my working memory there. That's a good question. Thank you for that really nice question. Um, Let me answer that last part first about having machine generated voice. We've really tried to look at that. A lot of my colleagues in computer science argue that the technology is so good now that you can't tell it's a machine generated voice. But I think to the degree that you can tell it's not a human voice, that could be problematic. That could um, cause people not to feel as engaged with the material. So I'm a little hesitant to um, to have machine generated voice until we're sure that it can convey the material with a proper emotional tone that we want. I do think we're getting that technology, but that's something I would really look at. Um, and your other question is about subtitles, whether they should be like an exact copy of what the person is saying or just an abbreviated version. Is that what you're asking me? I think there's some research saying that an abbreviated version might be better because if you have just a direct translation, then you run into the problem of the redundancy principle, and people might be trying to reconcile the auditory stream with the printed stream and not really be paying attention to the content, or they might be reading that long caption and not looking at the graphic. Since our visual attention, we can only focus on one thing at a time. So the benefit, I mean, the idea would be not to have anything on the screen, but sometimes when you have technical language or you're learning in a second language or um, um, the pace of the lesson necessitates it. I think having an abbreviated version could be helpful because then you'll kind of have two ways of saying the words, and when you try to figure out how they're related, maybe you're abstracting out the meaning of it. So if I had a choice between the full transcript and just an abbreviated version, I'd go for the abbreviated version.
See? Thank you for settling an argument that we sometimes have in our team. Thank you.
I mean, there might be some people who need the full version for various reasons, so that's probably good to have as an option.
Hello, Richard. I am from MIT, and I am part of what we call the Ivy Plus League. It's a league of all the Ivy League schools and media professionals from it. So my friends from Harvard, Yale, and other places say hi. They wish they could be here, but we're battling the government right now, so that's why some of them are not here. So, but we're huge fans. They just wanted me to say hi because they're like, "Oh my God, you're with Richard." I'm like, "Yes, I am." My
Thank you.
question is might be a little difficult, but my question is about people with cognitive differences and disabilities. Like, how do you adapt these principles for people who have cognitive differences and disabilities?
I thank you for that question. That's something that we've thought a lot about in our lab, but really haven't studied enough. Um, one issue that one obvious individual difference variable that's very important is prior knowledge. So we have looked at that. And I think it's important to know who your audience is because we have different design principles for beginners than for more experienced learners. And I would say almost all of our principles are really focused on beginners, less knowledgeable people. I think more knowledgeable people don't need as much support. So it's the beginners who benefit most from good instructional design. So that's kind of who we focus on. But in terms of other individual differences, one that I've thought a lot about is executive function, which is basically control of your attention, because attentional control, it's a huge issue in a lot of our students, K through 12, and also at the college level. Um, and one thing we have found is that lessons that are higher in distraction, that have more distracting features in them, um, scores on executive function correlate with performance for those kinds of lessons. But for less distracting lessons that are designed to kind of minimize extraneous distraction, then executive function scores do not correlate with learning outcome. So that's telling me that the more complicated media that we're using, such as virtual reality, which I haven't talked about, um, puts students who have attentional control issues at a disadvantage. So we need to figure out ways to help guide them through learning in virtual reality, for example, or learning from just a visually complicated video or other lesson. Does that make sense?
That makes sense. Sorry, people. Sorry. Apologies.
Yes. But I do think we need a lot more research on looking at individual differences and honing these principles adapting them to individual differences. And with the amazing advances we're getting in AI, it's something that's feasible to do now. So I think we really need to think about how we can adapt to individuals.
Great. Thank you very much for the explanation of the principles. And I'm looking at the audience here, and I know several of the audience who have made explainer videos explaining the principles, myself included. So it's really nice to see your explanation. And the question that I have is, when I talk to people about educational video, the first thing I say is theory of multimedia learning, cognitive load theory. That's the starting point, if you want to talk about it. And in spite of the many years of empirical, research and the evidence that says we know this works, this will help. My question is, why is this not more central to teacher training around the world? How can it be possible that every teacher doesn't have this in there? You have to know this as a starting point.
Oh, I appreciate that question. It's something we've all thought about. I think it's really important to um, communicate, scientific findings with practitioners, and it's something, we've tried to do at a modest level. And I do think we're making progress. Interestingly enough, I think the impact of these principles has been greater in the kind of adult learning, job training world rather than the K-12 or college world, because I think the world of business just moves a little faster, maybe. But I do think that's where these principles have had the biggest impact on kind of adult training and job training. Mm, I do think at the college level, I mean, I'm invited to give lots of talks at um, tra training for instructors, but the people who show up for those are the people who already care about it. And it's kind of trying to talk to the other people that is important. I've kind of given up, I shouldn't put it that way. I've kind of decided to focus more on graduate students, TAs, because I think they're more amenable to looking at how to help their students learn better. So I'm very involved in TA teaching assistant training. I think that's one way to go. And in terms of K-12 education, we know from the history of K-12 education that it is very slow moving and it doesn't change rapidly. There's usually about 10% of the teachers who will adopt new technologies, new ideas. So we just have to hope they will eventually convince their colleagues. But I do think, yeah, it's a slower process there.
Great, thank you very much.
Pressing down, yeah. Hi, Richard, again.
Hi.
Another practical question. Do you have any tips? We've heard some tips. We're here at the conference to kind of use the new technology that's available or older technology that's effective to kind of verify quite easily, like to what extent a piece of multimedia adheres to your principles. We heard about ChatGPT. You could ask it, but we saw firsthand that the results are often completely wrong. So I was wondering if you have a tip, and also if you have a rubric available, seeing as you've done all this research, that could be passed on to people like us who often have to look at videos and provide feedback.
Yes. I'm hoping you'll develop the rubric to tell you the truth, because I think you have probably a better insight into how to actually convey this information to people who need it. But I do think, yeah, a rubric would be helpful for people who are developing videos, because I know there's lots of like technical design principles that go into videos and everything to print media, but the actual instructional guidelines, we don't have, those are not as ingrained in the field. So I'd like to see them become more ingrained. Some of the technical requirements even violate my principle. Like I see textbooks want you to have a caption under the figure when I want it to be integrated in the figure. And they also don't care exactly where the graphic appears on the page. And it's very important in our principles where it appears. So yeah, I would love to see better guidelines, better rubrics for, say, designing video. And then your question about, was it about how the principles apply with new media like AI or things like that? Whoops. Yeah.
Okay, sorry, technical
Yeah.
issues. No, if you had any tips on existing technology or new technology just an easy way to kind of check whether a certain piece of multimedia, to what extent it adheres to your principles? It's kind of the same thing as the rubric, but just an
Uh-huh.
easy way to check it. We did experiment earlier today with ChatGPT, but it was very underwhelming. It created a lot of nonsense. It gave you an answer, but it not a good answer. So I was wondering, do you have any tips for us?
Yeah. I've been looking at that same question. I haven't found anything um too impressive, just like you. I think AI, um, I think it's been shown to be effective for grading. So that gives me some hope that we could eventually train it to also give us feedback on instructional design. But that's kind of a interesting question that I think it needs just a lot more study and a lot better understanding of how that technology works. But I agree with you. Don't I don't think it does a very good job of analyzing the instructional design of instructional materials yet. It would be great if it could.
Hello again.
Hi.
We talk about different generations of people and how they learn differently, and I'm on the cusp of being a millennial and X, so I'm curious, are there any specific principles that are more effective for an adult learner versus a younger learner?
Mhm. I think most of the principles that we've developed have focused more on adult learners. So I'm more confident that they apply to, say, college students, adults in the business world, or even high school students. We've done a few studies with younger learners, and the principles seem to apply. So I do think they can be applied, with younger learners, but I just don't have as much confidence because we have not done as many studies. I will say I'm also I'm not a big fan of the idea that learners today have a different kind of brain than the previous generation. I just don't buy into that. I don't think brains evolve that fast. I think we're dealing with this brain that has evolved over a long time, and one of the main characteristics is a limited working memory, and we just can't get around that. I don't think young people are better at multitasking. I think the research shows actually they're a little worse on average. So all this exposure that they have to online material is not making their working memory larger. It just doesn't work that way. So I'm kind of thinking we're dealing with the same mind for all learners.
Thank you.
Um, Looking at the developments and the rise of generative AI in schools and universities, um, should we be focusing on these multimedia theories and these multimedia principles, or should we be focusing more on engaging the learners in their learning spaces?
Yeah, I think that's a good question. A big chunk of those multibehavioral principles is aimed at engaging learners. I think when I talk about fostering generative processing, it's really saying how can we motivate or engage learners? So that's kind of the more recent research in multimedia learning. The original research focused on basically how can we reduce extraneous processing. I think that's how John Swiller and I both kind of started. Um, and then things just kind of evolved. So there's been a lot more work, I think, on this how do you foster generative processing issue. So I think that is important. And you know, generative AI we just don't know what's going to happen with this, but it's so interesting. I think there's so many possibilities. We've had this dream for such a long time that we could have individualized tutors for people, and it just seems like that's possible now. So maybe one thing would be to try and train those tutors on what are the best teaching methods. Um, I mean, it's something that we've been trying to do for the last 50 years, but we just didn't quite have the computing power, or I don't know what we didn't have, but we have it now. So it's so exciting to me. I don't think we can even visualize what it's going to look like, but I think AI, we know that the internet completely changed our lives, but I think AI is going to even have a bigger influence.
Thank you.
Sure.
Thank you, Richard. Thank you. I mean, what a fantastic place to end.